So in this little video, we're going to focus on the first of the two results that we have from the Squeeze theorem, the fact that the limit as x approaches 0 of the sine of x divided by x is equal to 1. And what I want you to notice about that limit is that the sine of the angle x is exactly the same as the angle that we're dividing by. And that's what we need to have always be true in order to use that rule. So we could potentially say things like the sine of 3x divided by 3x. The limit of that as x approaches 0 would be 1. Or the limit as x approaches 0, the sine of 12x divided by 12x would be equal to 1. But the angle and the expression in the bottom have to be identical for it to work. So you can see three limits here, all of which we don't have that angle and the denominator being exactly the same. So how can we deal with that? Well, with the first one, what we're going to do is we're going to think of this as the limit as x approaches 0 of 1/6 times the sine of x over x. And then we're going to use a property of limits that says that we can pull that 1/6 out front since it's a constant multiple. And we end up with 1/6 times the limit as x approaches 0 of sine of x over x. That's 1/6 times 1, or just 1/6. In a somewhat similar vein, on the next one, we have the sine of 6x over x. We need to end up with a 6 in the bottom. So we'll start by multiplying by 6 over 6 on the outside, times the limit as x approaches 0 of the sine of 6x over x. Then we'll think of that as 6 over 1 times 1 over 6, times the limit as x approaches 0, sine of 6x over x. And then we'll multiply the 1/6 inside, leaving the 6 over 1 outside. So we'll have 6 over 1 times the limit as x approaches 0 of the sine of 6x over 6x. That becomes 6 times 1, or 6. So what we're doing here is we're playing with the idea of constant multiples. I'm going to put a little division in between these examples here so we can keep them separate. So by playing with the constant multiples, either pulling constant multiples out or pushing constant multiples into a limit, we can get the angle and the denominator to be the same. We'll do a lot of this later in the course when we get into integration techniques. So this is some good early practice to kind of see how this works. The next one's a little bit more difficult. We have the sine of 2x over 3x. So nothing's just 1x. So we need to think about what we're going to do here. And what we know that we need to do in order to evaluate the limit is get a 2x in the bottom. So what we might do then is multiply by 2x over 2x. Or excuse me, 2 over 2. That's the limit as x approaches 0 of sine of 2x over 3x. And then we can push that 2 in the bottom inside like we did in the immediately preceding example. But that ended up giving us a 6 down there. All right. So what we really kind of want to do is swap these two things out. We want to think of this as 1/3 and think of this as having a 1/2 and swap their locations. So let's write this as 2 over 1 times 1 over 2 times the limit as x approaches 0 of 1/3 times the sine of 2x over x. All right, that doesn't get us the 2x in the bottom yet that we're looking for. Just getting us closer. So again, these are all constant multiples. I'm going to pull the 1/3 to the left, and I'm going to push the 1/2 inside because that's where we prefer to have them. So this is 2 over 1 times 1 over 3 limit x approaches 0 of 1 over 2 times sine of 2x over x. And now we've got almost the limit that we want. We just need to multiply things together. So we're going to end up with 2/3 times the limit as x approaches 0 of sine of 2x over 2x. That's 2/3 times 1, or just 2/3. Much more complicated, this last and third example. But the process still works. We just have to think our way through it. There are a variety of different ways to do this arithmetic, and you may see other ways for you to think your way through it, and that's fine. In any case, you should end up with the limit being equal to 2/3 when you're done here.